Tensiometers are used for soil moisture control and serve as an important tool for scheduling irrigation in various crops. In intensive crops, tensiometers are widely used. There are various types of tensiometers. In orchard plantations irrigated by spitters or drip where soil is just partly wetted, the use of tensiometers is rather helpful. The tensiometer readings help decide on better planning and more efficient irrigation scheduling. Let us connect a tube to the ceramic cup in order to demonstrate the principle of operation. The wall of the ceramic cup is made of continuous small pores of a defined size. The ceramic cup is the important part of the tensiometer. When filled with water and then tightly closed, the water flow outward is possible only through the pores of the ceramic cup. Let us insert the ceramic cup of the system into a dry soil. The soil should be in close contact with the ceramic cup. The dry soil next to the ceramic cup absorbs water from the system. Through the porous wall of the cup, when it's full of water, the water can flow in both directions. These pores are so small that air cannot enter from the outside. The water that flows out causes negative pressure or tension in the system. It's possible to measure this tension, which reflects the soil moisture tension in the vicinity of the ceramic cup. If we irrigate, the soil water tension will drop, and as a result, there will also be a drop of the water tension in the system. Tension gauges may be placed on the side of the tube or at the top, where they will also serve as a lid. Measuring the tension with a mercury manometer placed in the tube is a possible alternative. There are various types of tensiometers with mercury manometers. In this model, there is a mercury barometer in the system. Preparing a tensiometer before inserting it into the soil. Correct preparation ensures proper operation. It's preferable to fill it with water that has been boiled to release dissolved air. Releasing entrapped air which remained in the system. Dripping from the bottom of the cup starts after all the pores in the cup have been filled with water. Leaving it to drip for a few minutes to ensure the release of all the air from the cup. After refilling it with water, the gauge is connected and the system is closed. Placing it carefully and leaving it for a few hours. During this time, water will evaporate through the ceramic cup, which will cause an increase of the tension. And as a result, air that was dissolved in the water and entrapped in the system will be released, releasing more entrapped air, releasing the tension by inserting it in water before opening. Addition of a colored chemical to prevent development of algae. Refilling it with water. The color makes it easy to see if there's a lack of water. The prevention of algae is important, especially in mercury manometers, for a clear reading. Inserting the cup in water for calibration. The height above the water level is measured. In this case, it's 70 centimeters, which is 7 centibar. In this instrument, this is the zero reading. The ceramic cup should be kept wet until it is inserted into the soil. Otherwise, the cup will dry out and will again require preparation. It's also possible to transfer gauge tensiometers horizontally, but not tensiometers with mercury manometers. Placing of tensiometers in the field. It should be placed within the wetted zone. With a spiral auger, it's possible to place tensiometers in most soils. The diameter of the auger should be similar to that of the tensiometer. The hole in this case is to a depth of a few centimeters less than what's required, so that we can force the cup to its final depth later on. It's important to mark on the tensiometer its final depth in order to know how deep to insert it in the soil. The measurement is from the center of the cup. Inserting the ceramic cup to its final depth is done carefully. This is to ensure close contact with the soil next to the cup in order to have a continuous flow of water between the tensiometer and the soil. Pressing the soil around the tensiometer. At this station, there are two tensiometers representing different depths. The dripper is between the tensiometers. In sandy soil, a larger diameter soil auger is suitable, a Dutch auger. It's suitable also for gravelly soils. Under such conditions, it's sometimes necessary to try several holes in order to select the proper one. To ensure close contact of the ceramic cup with the soil, free of stones, the hole should be a few centimeters deeper than the required depth. Loose soil is added to fill in the place where the cup will be inserted. Addition of water ensures close contact of the soil with the cup. Pressing is important to prevent water penetration along the tensiometer. It's advisable to mark clearly the location of the station. A simpler way is to insert the tensiometer directly into the soil, if soil conditions permit. To obtain a good estimate of soil moisture status in the field, the tensiometers should be placed at representative points in view of water distribution and plant performance. Avocado irrigated by splitters. The tensiometers are within the wetted zone where the main roots are located. At one recording station, there is usually a pair of tensiometers. One is placed within the main root's activity to estimate when to irrigate. And the other is deeper to estimate the depth of wetting and amount of water application. Drip irrigation. When placed on steep slopes, the main wetted area is along the slope. Therefore, the tensiometer should be placed in the center of the wetted area and not, as usual, close to the dripper, where the slope has made the soil dry. At least one irrigation cycle after placing the tensiometers, it's possible to start recording regularly. It's assumed that within this period, an equilibrium is reached. Demonstration of water tension fluctuations throughout the season is an important phase in considering irrigation scheduling. However, to get reasonable readings, attention should be paid to correct installation. Because of poor installation, there is an accumulation of water around the tensiometer, even if the depth of wetting is shallow. The water penetrates down to the cup, and as a result, the readings do not represent the real moisture in the field. Attention should be paid to prevent this. Routine maintenance includes checking to see if there's a lack of water. It's recommended to add the water after the irrigation. Continuous use of tensiometers in perennial crops results in soil compaction, higher density of roots close to the ceramic cup, and poorer permeability of the porous cup. It's necessary to pull out the tensiometer once in 2 or 3 years for cleaning and maintenance. Cleaning with sandpaper will improve its conductivity. Opening the system to measure the rate of dripping so as to estimate the ceramic cup conductivity. Paying attention to correct installation as well as operation and maintenance will ensure efficient use of tensiometers for scheduling irrigation.